Now let's see the next part, which is nothing but rigid and resistant bodies. Rigid and resistant bodies. Now what is a rigid body and what is a resistant body, that we'll see. A body is said to be rigid if under the action of force, under the action of force, it does not suffer any distortion. That means distance between any two points remain constant. Okay, suppose there is one body, okay, and if we apply the force in any direction, okay, and its shape or its length, it does not distort, its shape doesn't change, or distance between any two points, suppose this is point A and B, this remains constant. If I am considering point A and C or point B and C, this distance remains as it is. That means it does not distort at all. That is known as which body? That is known as a rigid body. But ideally such body doesn't exist. We know that whenever we are applying force on any component or on any body or on any link, it will distort, it will undergo deformation. So to make the mechanism realistic, we will consider another kind of body, that is nothing but resistant body. Now what is resistant bodies? Which are real bodies? Resistant bodies are those which are rigid for purpose, they have to serve. Okay, resistant bodies are those which are rigid for the purpose they have to serve. Okay, that means suppose this is a link of a slider crank mechanism. Okay, this is a slider. Okay, this will be your crank, this will be connecting rod, and this will be your slider. Okay, we know that whenever some force is acting on the slider, your connecting rod moves. Okay, and then the crank will also rotate, or vice versa. If we rotate the crank, then slider will move horizontally, or it reciprocates. In this case, the forces are acting on different components like a connecting rod, then component like crank. On these forces are acting. Due to this force, there will be a deflection or deformation of each link. Which is negligible. So, for the purpose they are being made, okay, deformation takes place, but still those are doing the work. They doesn't fail. Desired work is being done. That's why they are known as resistant body. They resist to the deformation. That's why this is known as resistant bodies. It's not like that their deformation doesn't take place. Deformation takes place, but it is negligible. That can be neglected. So that's why it is known as a rigid body. And whatever mechanisms consist of different bodies, those are now known as a resistant body. Hence onward, whatever links and bodies we are considering for a mechanism, by default they are resistant bodies. Next we will consider now link. What is the link? Link, sometimes it is also known as kinematic link. A link is member or combination of member of a mechanism connecting other element and having relative motion between them. This is nothing but the definition of link. Okay, now what is the link? Link is member or combination of member connected with other element and having relative motion between them. So if I consider this as one link, okay, which is connected to the other link over here. So one link is moving in with certain velocity. Okay, one link is moving with certain velocity. Suppose this is my point O, this is A. So VA is the velocity of point A, okay, which is perpendicular to link OA, and this is my point B, and this is moving with certain velocity VB. Then what is the relative velocity? The relative velocity of A with respect to B is nothing but VB minus VA. Okay, so if two links are having relative motion between them is known as what? It is known as a link. Okay, it is known as a link. So link is nothing but a member or a combination of member of a mechanism connecting other elements. So this is your first link which is connected to the second link with the help of some joint. Joint is at point O. Then if link 1 and 2 are having relative velocity with respect to each other, then it is known as a link. Okay. Then according to this, there are different types of the link. One is binary link. Binary link is, it is having a single link. Okay. Second is ternary link. What is ternary link? Three links are connected with each other. This is the combination of links. The next is quaternary link. Quaternary link. Now what is quaternary link? Quaternary links are nothing but four links are connected with each other. Four links are connected with each other. That is known as a quaternary link. Now in this case, whatever joints are there for combination of link, here there is one joint, second joint and third joint. These joints are fixed joint like a weld joint, so that there will not be any relative motion between two links. So this is link 1, link 2 and link 3. So link 1 and 3 doesn't have relative motion with respect to each other. They move with the same velocity. Similarly link 2 with respect to 1 and 3 will move with the same velocity. These joints are not turning pairs, these joints are fixed joint like a welding. Similarly here also, all these joints for link 1, 2, 3 and 4 are fixed joint. Here it is a fixed joint, there will not be any turning pair. So this is nothing but the concept behind the link. Next we will see now kinematic pair. Next is kinematic pair. Now pair means two. Kinematic pair. Sometimes this kinematic pair is simply known as a pair also. Okay. So what is this kinematic pair? Kinematic pair is joint of two links having relative motion between them. That is known as a joint. Okay. Now if we see, this is first link and this is second link. Okay, these two links are connected over here and they are having some relative motion with respect to each other. Then this pair of link 1 and 2 is known as kinematic pair. Okay. Now then different types of these kinematic pairs can be made. So types of kinematic pair. Types of kinematic pair. So what are different types of kinematic pair? So there are different types of kinematic pair which can be made on certain criteria. So first criteria is type of kinematic pair is dependent on nature of contact. Second one is nature of mechanical constraint. Third, nature of relative motion. Okay, these categories can be again subdivided into different types. So I will again make the chart of it. Types of kinematic pair can be divided into three parts as above. That is nature of contact. In nature of contact, there are two types of pairs. One is lower pair and second one is the higher pair. Okay, we'll see it one by one. First of all, we'll see all the classification. Then nature of mechanical constraint. Nature of mechanical constraint. This is divided into two categories. One is closed closed pair, and second is unclosed pair. Then types of kinematic pairs are divided in third category as nature of relative motion. These are divided into 5 different categories. Let's see those categories now. First is sliding pair. Second is turning pair. Third is rolling pair. Fourth is screw pair. And last one is spherical pair. Now let's explore this one by one.